Good evening, everybody. With a lot of pleasure, happiness, and elation, I would like to welcome our uh, very own. Never met him. I'm meeting him now virtually, but our very own Dr. Björn Sostu. Uh, he is the inventor of C++. We don't have to say much more, but I would like to take a minute. His non-research interests, include general history, light literature, photography, hiking, running, travel, and music. We have seen him talk about the Vasa, haven't we? Uh, Also likes reading, light literature, popular science, history, running, traveling, and hiking, and dining with friends. That's interesting. His research interests include distributed systems, design, programming techniques, software development tools, and programming languages. To make C++ a stable and up-to-date base for real-world software, he has been a leading figure in the ISO C++ standards effort for more than 25 years. I would like to welcome you, Björn, uh, Charles Stark Draper Prize winner. It's a very great pleasure to have you here.
Thank you very much. It's
India,
fun to be here.
India thanks you. So we already started some questions in a thread on Discord. So can I start with the top voted one right now?
Please do.
So if there's a way to go back now, getting into dreamland, if there's a way to go back to the drawing board and completely recreate C++ from scratch, what would that language look like? Features that would be removed, added, redesigned?
Let's see. That's what I think of as the time machine question. And of course, you can't do it. There are things I would like in modern C++ that just doesn't fit on a computer with 1 megahertz and less than a megabyte of memory. And so you have to start out primitive, get the concepts right, and then move forward. There's the real world. C++ wasn't the first programming language, so you don't have the freedom to choose. In particular, I could not choose things that are radically different from C. So the C declarator syntax, for instance, I mean, even Dennis thought that was a bit wrong, but it was the only thing that fitted on his early PDP machine with only 48K of memory. And I certainly would not have chosen to have conversions to and from unsigned implicit. That just doesn't make sense. A conversion grid has to be a lattice, one way, with no information losses. This is very hard to do. So I would say that the features of C++ are roughly the right set of features, but all the details are, in retrospect, not as good as they could be. So in retrospect, it's not the radical change to the language, but you could simplify and avoid a lot of the problems. When people want new features, they say, why didn't you do that back in the 80s or 90s? And most of the suggestions I hear just couldn't have been done in that world. Some of them I thought of, some of them I didn't think of, but many just require either invention, which could have happened, or compute power or community understanding or education that I couldn't have dealt with. I also sometimes says I shouldn't start arguing with the 1980s vintage Bjarne. He was at least as smart as me, and he knew the environment at the time better than I do now. But there's one example where I am sort of ever so gently kicking myself, because there was something that if I had been smart enough, I could have done better. Templates are unconstrained as they came into the language. I was looking for a way of getting three things: full generality, optimal performance, and really good interfaces. And I couldn't get all three. Nobody knew how to get all three. We now know how to get all three. The third leg of this tripod is concepts. Concepts defined as compile time predicates. I think I could have done that if I'd had the idea. I think the environment, the compilers would actually have simplified the creation of templates back in the 80s, but I didn't have the idea. Everybody was modeling that kind of stuff on classes, and that just isn't the right way. Predicates are much more fundamental, much simpler. Hey, we've had those things since the ancient Greeks. Very useful predicate logic. And that I could have done. But the major feature set, I think, is correct. And I think there's hardly a major feature that we couldn't agree could have been done better if we had had 2020 hindsight 20 or 30 years ago. That's hard. By the way I address that is through guidelines and checkers, rule checkers, and things like that. Trying to get people to not spend all of their time in the dark corners. But they seem to like spending time in dark corners.
Yeah. Good. I'll go to the next one. Does the new 3-year release cycle make it difficult to disseminate and master concepts and libraries before the new one is released? Academics, companies are not so fast to adopt them. Many are still on C++ 11.14.
Actually, I think implementers, library builders, and also industry is catching up faster than they were. Certainly the adoption of C++ 20 is faster, much faster than the adoption of C++ 98 was. And people are always complaining that there, one, is too much change and we can't keep up, and two, there's not enough change, we want new things. And balancing those two is a real trick, and it's very, very difficult. But I think there's this way of thinking of a balance. If people on both sides complain equally much, you're doing all right. And I think the complaints about too fast and too slow are reasonably balanced. I would generally like to work faster on major things, on fundamental things, things that change the way we think and build systems, and work slower on minor little details that allows us to write a particular thing slightly better. But again, people love fiddling with little things and they get scared about big things, so I have a problem there. On average, I make progress, not as fast as I would like, but it goes. I've got concepts now, right? We've got modules.
Yes.
C++ 20 is half a year old, and the compilers are implementing it reasonably well. And we shouldn't complain that half a year into a 3-year cycle, we aren't all the way there. And the pandemic doesn't help at all.
Yeah, truly. Right, thank you. think I'll go to the next one. With the evolution of cheap, fast commodity hardware, the performance argument for compiled languages seems to be losing weight, especially for the high-level application development. How do you see C++ competing with newer, easier to learn but slower languages like Python, JavaScript? What would need to happen for C++ to ward off the competition and remain the language of choice in the coming years?
I have heard this argument constantly since the mid-80s. Machines are now getting so fast that we don't need languages like C and C++. We will do all our development in Smalltalk and Lisp and whatever languages. The point is that underneath all the easy-to-use languages, you find something that needs to deliver performance. So you look under most Python applications and you find a C++ library. C++ is what runs Python. And JavaScript. What do you think your JavaScript engine is written in? So we have these curious things with C++ being translated into JavaScript that is then executed by a C++ program. Ta-da! People have always wanted more, and that ends up being that hardware is getting faster, but human expectation is getting even more demanding. And so you look about under everything roughly, and you find C++. You find it in the Mars helicopter, you find it in TensorFlow, that's the basis of most of the AI today. You find it in all the mathematical libraries for Python, the PyTorch. What do you think the communication channels underneath Python is there? They communicate with that event system written in C++. I wrote a paper, I think early this year, which is posted on the WG21 site, the C++ standard site, where you can find just about everything, and called C++, the Invisible Foundation of Everything, because it's not a very detailed paper. I just thought I'll summarize a few of the things that people tend to forget because they're big things. And one of them is that C++ is probably not the ideal language for a non-programmer or for a casual programmer, a specialist in something that is not programming, but using programming, which is most of the people in the world. But it is the foundation of the tools they're using. And so that's an important thing to remember. The other important thing to remember is that the C++ community has been steadily increasing since 2005 or thereabouts. There are now between 5 and 6 million of us, which is it's a lot more than there was when C++ was deemed the dominant language. There's never been a dominant language. That's you can dominate an individual field, but not the whole picture. C++ never did, Fortran never did, etc. So that's a fake argument. So C++ is more widely used, more important, and more used than it ever was.
Absolutely.
And every year since about 83, people have declared that it's dead or dying. They've been wrong every year so far.
We had the talk, The Beast is Back by John.
Yeah, I unfortunately didn't hear that, but that was in the middle of the night for me, so I have an excuse. I think you have to remember that C++ is not a language for everything and everybody. It can do everything, and most people can manage it, but its core domain is places where you need to deal with performance. You need to use hardware well, and you need to manage significant complexity. If you don't have complexity, you can get the performance out of assembler or C. If you don't have performance requirements, you can use any language. If you need both, you don't have many choices.
Oh, yes. All right. So the next one is by Swaminathan. Does C++ fit into the new computing domains like quantum computing?
I really don't know. I don't know much about quantum computing. I have talked to some people that built quantum computers, and guess what they programmed their infrastructure in? C++, of course. I do not know if that's true for all quantum computing efforts. It's unlikely to be true for everywhere, but it's true somewhere. And so when I say foundation for everything, it's a good approximation, but don't take it totally serious. And quantum computing itself is something really different and really weird. And I think it'll remain a gadget sitting on the side of general purpose computers so that you can ask it questions. It's like an oracle sitting on the side. You ask it a hard question and back comes an answer. But it's not programming as we see it. It's a bunch of equations. Currently, you will do best with quantum computing if you're a theoretical physicist and are used to manipulate advanced equations. And anyway, we need many more qubits before we can get really important stuff. But I imagine the quantum computer being sitting on the side of the general purpose computer. We have an interface that asks questions, and then you have the general purpose computer with all the general purpose stuff, which will have a bunch of languages, some geared to, say, physicists, and some geared to software engineers that built the infrastructure. And in that domain of the engineering, the foundational stuff, you'll find the C++. Not over on the, I don't think over on the gadget that actually does the qubit management. But I may be wrong. It may be there, but I wouldn't know.
Okay. Next one. Is there a feature that you wish C++ had?
Oh, sure. I mean, I'm always an optimist, and we learn things, and that learning has to be turned into tools. And so I would like us to have static reflection. That's reflection is good, but not if it becomes a random walk through data structures at runtime, because then you don't have controls, you don't have guarantees, such. But statically, it would be nice. You can get a lot of flexibility out of that without losing control and guarantees. I would like a form of pattern matching. I'm working on that, functional style pattern matching, that will simplify some of the decision points in the programs. I think that's the sort of the main programming language features that I'm looking at. I'm looking forward to seriously using modules. We need standard modules in the to present the standard library, and we're working on that. So we're going to get it. That's sort of the main thing. What I really would like, and I've been working on for years, is a good representation of a C++ program for tool building and analysis. Together with Gabby Reis, I designed something called the IPR. I'm not good at naming, internal program representation. It's a representation of a C++ program, actually of a generalization of a C++ program. It can handle more things than you could express in C++. And you can do minimal traversals, that is, If you traverse a program, it is guaranteed to be the minimal number of hops. That's performance. And it is compact. It is basically minimal in size because it doesn't store anything that could be known statically. And this we did in about 2007. And there's a paper about it. You can find it on my publication page, and you can find the links to the open source representation of it. But when we tried to publicize that, people didn't get it. They said, well, this has been done before. Yeah, for toy languages, not for C++. And anyway, we were told that one, you have misunderstood C++ because it's not what we thought it was. And two, GCC already does it. Now, I know C++ reasonably well. Gabby was the French national representative to the Standards Committee and knew C++ very well, and was in an office 2 doors down from me. And he was the shipping manager for GCC. We beat GCC performance for traversals and things like that and sizes by about a factor of 30.
30?
30 times faster. Okay.
Wow.
We couldn't publish that paper. They didn't believe us. Okay. So fast forward to this year. Gabby now is one of the leads at the Microsoft compiler development. And that's one of the reasons why Microsoft compilers are much better than they used to be. And they have very good modules, very good concepts. I work with concepts with him also. And if you look at module performance, it is compiling very often 25 times faster than if you use includes. I have seen, depending on what you compare, I've seen between 30% improvements and 80 time improvements. There's a paper on GCC, on isocpp.org. It was up there this morning, that somebody did an experiment and it came up 23 times on average faster compilation with modules and versus includes. There's a German engineer, I've forgotten her name, who keeps getting 25%. I wrote a paper for WG21, the website, you can find it. Take a very, very simple example. Hello world. Traditionally, include IOStream, main hello world. Okay, that's the old world. That's what we've been doing since the Dark Ages and what most people are still using. Now, if you can get your hands on a modularized version of the whole standard library, not just IOStreams. So it could import STD.
Import, of course.
Import. Semicolon. And then main hello world. STD : C out of that. 80 times faster. Okay, so we weren't that far off with this 33 times faster than GCC at the time. Okay, they didn't believe us. You can now go and try it.
Even in template heavy code, which involves a lot of generating, right? Still, okay.
Yeah, I mean, you can go and see the numbers. I also did what I thought was a more realistic small program. I just wrote a page where I used a little bit out of the, I think, 9 most popular standard library header files. So algorithms, vector, random, things like that. They're heavily templatized. They're all templates, basically. I'm still getting these 5, 10, 15 times. Go and try it. It's fun. Now you can go and try it. You don't have to read academic papers and see if you believe them. Yeah. And you can download the IPR if you want to build tools. The previous talk was about static analysis. Static analysis is immensely important, and it is underdeveloped because it's too hard to analyze C++. If you have the IPR, it has been made into a graph for you that you can traverse. So if you're into tool building for analysis of programs, that is a good place to look.
Okay, nice. Next one by Navonil. We have modules now. Do you think the committee will also set up guidelines for a unified package manager someday instead of having a myriad of options like Conan, VC package, etc.?
This is a big problem. This is a typical problem for C++. We are disorganized, uncoordinated, and the standards committee traditionally is not allowed to talk about tools. It's under ISO rules, it's about language, which we cheat and try a little bit about tools, but it's hard. Furthermore, there's endless commercial interests behind this. And so the problem with C++ is essentially never that we haven't got something. It is we've got 25 of them. And then we can't choose and people can't share and things like that. So I would love to see a standard package manager. I'd like to see a standard thing so that says download this thing and use it. Of course, if in many organizations can't just download things, but there should be a way of easy downloading things. And if you can't do it for safety and security reasons, you can at least get it and then start your analysis. And I would love to see that, and I'll encourage something to do, but that's all I can do. I cannot change the fact that there is at least a dozen package managers that are halfway reasonable, and none of them want to go away. They don't all think they can take over the whole world, but they all think they can take over some part of the world, and so they compete. What I would like to see, and what I suggested at a CPP-Con keynote, I think 2 years ago, is that what if we had an interface, a very simple interface that's saying, I would like this package, I'd like to open this package. And so something that takes about 3 lines to get something and make it available. 3 short lines. Now that could translate into something that could use any of the package managers, so that you were insulated from the quite interesting and difficult implementation details and how you merge things, how you get things, how you determine, how you see whether something has changed and all of that stuff. Most of that can be put behind an interface. So that's the way I think we might eventually end up. But the problem is we've got too many of them.
Okay, next one. What tradition associated with C++ you dislike? Asks Ronak.
What?
What tradition associated with C++ do you dislike?
Okay. Too many C++ programmers wants to be clever and do clever things. They love obscure language features. They love showing code saying, look at this. Do you understand it? Yeah. I do, you don't, so I'm smarter than you. I hate that argument. It is a very faulty way of logic. The aim should be simplicity, using the simplest language features in the simplest way to solve the problem. not showing how clever you are and how you can do things really complicated. And so it's hard to pick some answer to that question, but people being overly clever is part of it. And that very often means that they want to optimize everything and write really low-level code rather than think about what is the fundamental concepts and how can you represent them most cleanly in your code. And then you can later go and optimize. If you have a really clean definition of what you're doing, if it's not fast enough, you can optimize it. If that's not fast enough, you can keep optimizing it. C++ is very tunable. Eventually, you can have an interface and you can end up touching the hardware directly. I mean, if nothing else works, stick in some inline assembly. I was using vectorizing operations 20 years ago on machines that had really good vectorization, but the compilers, of course, didn't know about concurrency, not 20 years ago, or parallelism. That was complicated stuff, and you could sort of optimize a vector interface in a couple of hours or a couple of days to run optimally. And so keep it simple and then optimize. Don't optimize just because you can, and so that you can impress your friends.
I'll take the next one. It's from Hemil. What languages would you recommend a beginner who is actually interested in computers and programming? The context he specifies is C++ was my first language. I quit thrice 3 weeks before I finally sat down to learn C++. Thrice in 3 weeks before he finally sat down to learn C++ because I did, I understand things like stack and heap, lifetimes and objects, etc., which my friends who started with Java, Python, JS do not understand that well.
Yeah. I don't think there's a single answer to this. I would turn it around and saying, so what is it you want to do with a program? What is it you want to do? And if you want to go into the domain that is close to the hardware, then C++ is a really good answer. If what you want to do is to stay away from the hardware, if at all possible, because you're a biologist or a physicist or a historian, then C++ is not the right answer. I was faced with that question, must be at least 15 years ago, when I was a professor in Texas, and somebody came up and showed me how they were teaching the young engineers. And I opened my mouth rather wide, expressing horror and disgust, because that was cruelty to students and they didn't deserve to be mistreated that way. That was roughly what I said. So, of course, this was a booby trap. The guy turns around and says, "You think you can do better?" Of course I can do better. So I ended up teaching all the freshman electrical engineers and computer engineers. The computer scientists wanted Java instead, so they didn't do it. Okay, so I looked at the C++ textbooks, and for about 2 weeks, I was walking around with smoke coming out of my ears saying, if that's C++, I hate it too. But of course, my opinion was it wasn't C++. It was just really bad presentation, fiddling with low level. There was a book that had a whole page about how to write a for loop. And no, it was not about loop invariance. It was about syntax details. For loops? I mean, we learned the fundamentals of for loops and conditions and such in kindergarten. If the light is red, stop until it turns green, you go. We know that in kindergarten, we just need a syntax for it. Okay, so I ended up writing a book about it. And that's the book with the swans on it, programming, practice, principles and practice using C++. It really is a programming book that uses C++ as opposed to a book about C++ syntax. And so there's my approach. I actually was challenged to say, if you want to learn C++, how do you do it? And this was my attempt, and it's a second edition, so it has benefited from a few thousand students taught by me and others. So it's not just as people it's work because Bjarne does it. No. First of all, I do things my way, and sometimes it works and sometimes it's not ideal, but it was also done by others. That book could be improved, especially in the graphics area, but it's the only book I know that teaches beginning C++ that actually teaches graphics. Very simple graphics, trivially simple graphics, but I found that my students, if they couldn't print pictures, didn't think it was programming. And anyway, graphics is an excellent way of teaching object-oriented programming. So always you have a problem, you want to do something. What language features does C++ offer to allow you to do that? And that's how you come into to class hierarchies, for instance. You have pictures, and they organize natural hierarchies, and so we need them. We do it. We don't just introduce a language feature because it's there, and then give a cuddly animal example or something like that. You have to find the problem first. So if you are going into the engineering part of programming, which is, my guess, between 15 and 20% of all programming, C++ is a great language to start with. You learn, as the person that stated the question, you learn the fundamentals. I mean, you learn stack versus heap, you learn lifetime, you learn scope, you learn resource management, you learn error handling. In my book, error handling is chapter 5. Most books on C++ and other languages don't do error handling. How can you write anything without error handling?
Reminds me of your quote in Uncle Bob's book, right, where you said an articulated error handling strategy. You mentioned this in in Beautiful Program or Clean Code definition.
Oh, see, yeah, I've not forgotten that.
Yeah. Okay, superb. And very related, can we expect a book specific to C++, but like a tutorial and unlike reference authored by you?
I think you've got one. It's called A Tour of C++.
Tour of C++, the red one.
It's an overview, and it is not for beginners. If you're a beginner, look at the Swan book. But if you are already a programmer, if I don't have to tell you what a loop is, and you want to know what C++ is, look at A Tour. It has a nice feature. It's about this thick, and you can read it in a weekend. Many people have. There are people who claim they learned C++ in a weekend.
In a weekend?
In a weekend. That's an exaggeration, of course. They have seen the fundamentals, but they haven't tried it. It's like having a correspondence course in bicycling. First time you try to use your theoretical knowledge, you fall off. So you have to experiment. But you can actually, if you are an existing programmer, you can get to the point where you can start experimenting and trying out things with understanding of the underlying concepts to test that you actually did understand them in practice. You can do that after a weekend. This is pretty outrageous given the traditions there, but this is for people who are already programmers. 200 pages. And it does the language, most of the important features, and it does the standard library, most of the important library conventions. And as usual, I threw in a history chapter because I think history is important. As a professional person, you have to know your history, have to know how things came about, know something about rationale. Every profession has that view, and if you don't, you're not a professional. It's about like that. Would you claim to be a physicist if you hadn't heard about Newton? If you could explain a little bit about what Newton did and why he was important. With biology, try Darwin or Mendel. With computing, there are things that we have to know. We could mention a lot of names, but now we start. Different parts of computing has different things that has to be understood. And of course, in a tour of C++, I focus on C++. It's not a general history of computing.
Right.
The Swan book, programming book, does have a history chapter, and it does list people that has influenced C++ with nice photographs of them.
All right. What resources do you use to keep yourself up to date with the various features, additions, and improvements to C++? Asks Rahul.
Oh dear, that's hard. It is hard to keep up. I read a lot of stuff to do with the standards committee, of course, because I have to. That's part of my job. It's part of what I do. I also work with people in my day job, so I see projects. Whole projects. So I know about build systems and things like that. But on the web, it's a fire hose. There's just so much there, and I can't keep up. And it's hard to know what is real. That is, people present things as if this is what's real, this is what everybody's using, and then you find it's two guys and their dog that's doing it. There's so many clever ideas, there's so many clever systems that are many years from deployment. So distinguishing between what is hype and what is real, and what is real now and what is real in the future is just very hard. And yeah, there's articles, academic and industry. There are lots of videos. I mean, the C++ Foundation and CPPCon started the trend of putting all the videos for free on YouTube.
Indeed.
I had a little bit to do with that because I'm one of the directors of the foundation and so on. So that has been there. The problem is selection. Personally, I prefer to read stuff rather than to view it. I guess I'm about to be the minority in that, but so I mentioned the videos, I produce videos, but I prefer to read. And so one thing that I do, I look ever so often, I look at isocpp.org, at the, or is it .com? I can't remember. That's the foundation's website. And I mean, like this morning, I found the article about modules that says you can gain 23% on average, 23 times on average. That was what he measured for his project. Nice stuff.
Super.
Especially since I predicted it.
You did,
almost
right?
20 years ago. Yeah.
With modules, sorry, I just took the opportunity. With modules, the compilation flags are important, right? So if you have pre-compiled modules, that would interfere or mismatch.
Modules are always pre-compiled. You have to compile it first to create the internal representation, and then you use it. So think about it. You build your module. That takes time, but it's done. It's done. So over there, you do it once or once every month. So however that one changes. But the standard library changes about how often? Every half year for an implementation. Okay, so that is not the factor that I am taking in. If you took and built it from scratch every time, you wouldn't have a win. If you build it each time there's a new version of the library, you win big. It is much easier to digest representation of the code that you are importing. And so you do template instantiation, but you don't do template instantiation from the tokens and characters. You do it from a graph representation. That's where you get your wins.
Super duper.
You've done your work last month.
Right. It's time to reap the benefits. There's one, so I've heard and read perhaps somewhere that C++20 is now feature complete as you envision in design and evolution of C++.
It's close. As ever, anything to do with me and my thinking is I work with approximations. So I said it was close to what I wanted in DNE, Design and Evolution of C++, written in '94. And I said it was close. And people took away the close and says it is. I mean, there are things I would like, but I mean, like I would like a uniform core syntax so that we didn't have to have this fiddle whether we have functional style or object-oriented style. I mean, x.f should be the same as f of x. That's in DNE, and I didn't get it. But I was looking for modules, I was looking for concepts. There's a 3-page introduction to templates that is an apology for not having concepts. This is how I know that if somebody had explained to me how to do modules, I would have grasped it, I would have understood it's important, I would have been able to implement it. So things like that is there. And in that sense, we're very close to what I was envisioning back then.
You had reflection there?
No.
No.
But I don't have reflection today.
Oh yeah, yeah. I was thinking of what else maybe.
Oh yeah, no. It's. I mean, I don't claim to have thought of everything. I just claim that C++20 has most of the things I was thinking about then. It has more things. There's things that aren't in either, but it's close. I have to give my CPPCon keynote this year roughly on that topic.
Oh.
I promised to say how C++ today reflects the ideals of C++, starting back from '79. And that will exactly be, that will likely be the talk that that's the answer to that question.
Okay.
And I can assure you, I'm not going to say C++ is perfect or it has everything that anybody can want. I just don't do such things. But I will say that what we have today follows ideals and principles that we didn't just make up overnight yesterday.
Okay, next one. Why were contracts dropped from C++20? Perhaps beyond concepts, light is, oh, sorry, that's contracts. I beg your pardon.
Contracts.
So why were contracts dropped from C++20? Will they make it into C++23? That's a no. And is there a rethink on its design?
It turned out that people couldn't agree what contracts was or should be. People couldn't decide on a minimal initial version of it. Basically, some people thought it was a way of inserting tests that could be checked. Some people thought it was an optimization feature that allowed you to optimize more. And some people some people thought it was a static analysis thing that allowed you to deduce what was right or wrong. And there was people who wanted features so that you could recover from a contract violation. There are programs that must not fail. There are people who says that you should always terminate if there's a contract failure. There's people who says you can, if there's a contract failure, there's an undefined behavior, even if you are not testing it and things like that. People just couldn't agree. And there's still debates going on. There's a new proposal coming up for a minimal solution. I personally doubt it's a minimal solution. I think it's too small, but we'll see. And I would be shocked if it made C++23. It's not there yet. Too many people with too many needs, too many ideals, too many, it's a very diverse community. It's much easier to design for a smaller community or for a community that has a more clear focus on what it's doing. The C++ community, as I see it, has to do with utilizing hardware and managing complexity. It's much easier to say we're doing this for embedded systems, or we're doing this for classical systems programming or something. C++ is a domain of where it belongs is just too broad, which means that you have people coming in and you're trying to get, say, games developers to agree with space, with rocket scientists. Yeah. Or it's hard. And with contracts, it just didn't work for C++20. We had it voted and then somebody objected strongly at the end and it fell apart. Ooh. I think we should have had what we had in for C++20. We should just have taken it and then found where it wasn't good enough and fixed it. I think it could have been fixed by extension rather than change, but that's not what happened. Lost that one.
But then fixing anything in the standard library anyway, is it really an option? I mean, we are stuck with things.
Well, it wouldn't be in the standard library.
Or language.
We do often do things with a three-year cycle. It becomes feasible and probably ideal to do a little two-step. First, you put it into the language. Now people can experiment with it. And then you vote it into the standard library. Because now people have had a couple of years to actually experiment with their experimental versions of the standard library, so we know what works and doesn't. They will also find that if the language feature is not quite right for some domain like the standard library, then you can fix the language and then fix the library. So this little two-step language then library is good. Of course, you never design a feature without also thinking about the library, but being able to actually experiment and actually try out things at scale can be done because we have the 3-year cycle.
Are TS not giving us enough input, feedback?
Sorry?
Are the TS technical specifications, they're not giving us enough feedback?
I'm not a fan of technical specifications. They are almost as much work as the getting into the standard, and implementers won't move till everything is done. Yeah. And then people come along when they should move from the technical specification into the language, and they want massive changes so that what we learned from the technical specification may no longer apply. I think in a few areas you can use technical specifications, but many of the things people think they get out of technical specifications, they don't actually get. So one of the things that we recommend is that when you propose to make a technical specification, you are supposed to write clearly what do you expect to learn from the technical specification and how long will it take. That is, you don't just do a technical specification. A technical specification should be an answer to a question.
Makes sense.
State that question clearly. If you look back in the technical specification, several of them didn't have that.
Yeah.
This actually gets me to another point. Who was that we that I just said? There is a working group. There's a group in the standards committee called the Direction Group, which is just 5 people whose job it is to look into big issues and issue recommendations. We don't propose anything for votes. It's recommendation. People can see, but somebody has to look into the big issues. Somebody has to issue recommendations. So there's 5 of us with a rotating chairmanship, all people with a strong track record in the standards committee and in the community with different backgrounds. Let's see, I'm on it. Michael Wong, who's into embedded systems, self-driving cars, and a bit of gaming. We have Howard Hinnant, who is one of the best library writers and also is doing systems for, I think, for these virtual currencies. And there's David van der Voorde, which is one of the best compiler writers. And there is Roger Orr, who has a lot of experience with applications, finance and otherwise. So the idea, and we all have a very strong track record over more than a decade. So it's not our job to solve any problem. It's our job to find problems and give recommendations of directions to do it. That's why it's called the Direction Group. And that was a group that recommended that a technical specification should answer a question. And you shouldn't start that without knowing what it is you're trying to figure out.
Then we have a question from Gajanan and a similar one from Samir. They ask, what are your thoughts on Rust? And the other question says, what are your thoughts on Rust? How do you think will C++ and Rust go along in the future?
Let's say I don't think as much about Rust as people think I should. It's nice to have a language that's trying to build a better language on many of the principles that C++ has, like getting RAII and that kind of stuff. On the other hand, new languages always look simpler and easier than older languages, and then they grow and add complexity. So I don't know what's going to happen with Rust. It'll probably survive, and in that case, C++ and Rust will find a way of coexisting. I don't think I want to say that much more about it. It's also still changing, so that I fear that my understanding of Rust would be a little bit, well, rusty. I haven't looked at it in the last year, so it'll be outdated.
Okay, cool. Then Vivek asks, how would you compare C++ with Golang? with regards to programming for performance and handling problems complexity?
I think anything Golang can do, C++ can do. And the opposite is not true. Back before C++ 11, Matt Austin and I proposed basically channels as a library implementation in C++. If you want Go channels, go build them. It'll take you at least a week. But that's what it is. We wanted channels and we got futures. They are very related when you implement them. It's just there's only one in future, and a channel can do a whole bunch of them. The first library with civil classes back in 80 had some concurrency features, and they had a message queue. And I think we should have had it. And I wish I'd had time to build one for C++ 20. And then that question would have been meaningless. By the way, I can add something to sort of the Rust answer. The main claim of Rust is sort of safety, memory safety and such. C++ can deliver resource safety and memory safety, and we do it through the C++ core guidelines. Another thing that you can find on the web. It's a set of rules, and there's a checker that goes with it that's not perfect yet, but it's deployed with Microsoft Visual Studio. I wish it had been standalone, but it isn't yet. I hope there'll be more implementations of it, because you can't follow a complex set of rules just by remembering them. You need a checker, and it's good. So you can actually at scale guarantee memory safety and resource safety if you follow the rules of the core guidelines. Now, if you allow arbitrary complex code and arbitrary complex data structures, you just can't do that. You run into the halting problem. It's not just difficult, it's impossible. Furthermore, when you have dynamic linking, it's, let's say, so difficult that it could just as well have been impossible. And so you have to follow some simplifying rules. And for instance, passing pointers through interfaces, there's some very simple rules that you can follow. If I get a pointer from your program, should I delete it? May I delete it? So the answer is that you have to have a model of whether it's an owner or not. We can use ownership abstractions like vector and unique pointer, so the answer is solved at the high level. At the low level, you need an annotation. But basically, the fundamental rules for safety is that for memory safety is that a pointer must always point to an object or be the null pointer. If that rule is obeyed, then when I get a pointer from you, it'll point to something or be the null pointer. If I make a pointer and give it back to you, it must point to something at the point where I give it back to you. It must not point to a local object or something that doesn't exist. It's very, very easy to check, and you can go and try it out. The implementation is not good enough. It's not using a general enough way of implementing things, but it's getting there. It needs a combination of static analysis and flow analysis. And you need to handle things like invalidation, which it does. And so there's a set of rules. If you have a set of rules, then you can do local static checking. As a previous speaker said, static checking doesn't scale. It will scale if you limit the use of the language to things that scales. I mean, there's a reason local static analysis works beautifully. Global static analysis is unaffordable for real code. So we only use local static analysis. We can set the rules so that that is true. Go read the document and you'll see what I mean. Also, look at the WG21 paper from last month by me on type and resource safety, which addresses this question.
Okay, thank you for that. Next one, will C++ take over Java in upcoming years? Can you please share your view?
Oh dear.
Your favorite question?
I actually, no.
I know.
People always want language comparisons and they want to know which language is going to take over or which language is dominant. I
know you don't like to go there.
I don't spend much time thinking like that. I look at languages and I see what they're good at. And if they're good at something C++ isn't good at, I try to learn from it and give credit from where I got the ideas from. But I don't see the world as a competition for dominance. A lot of people do, but if I did, I wouldn't have time to do any work. I just look at the language, try and improve it. And Java will not go away in our lifetime. There's just too much of it, too much infrastructure, too much tools. I find it extremely verbose and slow, but other people find it is manageable with tools and fast enough for what they're using for. And if it doesn't run fast enough, you can always call C++ to get the work done for you. And that happens a lot. Java and C++ coexist. I know when Java came out, the people from Sun was advertising that it would absolutely kill C++ in 2 years. This is an exact quote. Not very nice. They called C++ and C for garbage, pollution, things like that. Well, I guess they've grown up a bit and we coexist, and there's no need to be rude. The languages have their uses, both.
Okay, what's the story behind making of virtual and friend functions in C++?
Try again.
What is the story behind making of virtual and friend functions in C++? I mean, why have this?
Okay, yeah, sure. I mean, now we're going back to 83 and before.
83?
I felt, let's take friend functions first. If you build classes, you get member functions, right?
Yes.
And you get the traditional way of x dot f of y. And I should have thought deeper about that because you don't need that. But that was the way the object-oriented languages were designed. This was what I was used to from Simula. It seemed important. And if you wanted a virtual function, you have to somewhat say this object's function, and you have to look into the object to find where the function is. So I guess that's the answer why we got virtual functions. I'll get back to that in a second. On the other hand, the idea of saying 2 dot square root seems absurd. I'm trained as a mathematician. Square root of 2 is something that should work.
Functions.
It didn't even in C because you couldn't declare that the argument was an integer. The C programs crashed at that in those days until I fixed C to have function prototypes. So you can now say double square root of double. You couldn't do that before I got my fingers on it. By the way, in language wars, there's always this C++ language wars. I'm a good friend of Brian Kernighan's and knew Dennis very well and discussed things with it. I reckon I'm probably the main contributor to the C language after Dennis.
Oh, wow.
And we discussed it. I don't want language wars with C if I can help it. Anyway, so I wanted square root of 2. And I also wanted the virtual functions that looks into the object. What I did not realize at the time is that that is syntactic sugar. F of x works beautifully.
Yeah.
You just, if x happens to be if there's an object that's the first argument or something like that, you can just sort it out. You don't have to bother the programmers with the details. The person who defines the function, the person that defines the class can deal with it. That's in D&E also, by the way, because I had realized by then that I had done things too complicated. My only excuse is everybody had basically done that mistake. So maybe not the Lispers, but certainly Simulan, where I got most of my ideas from, and Smalltalk. But basically, we have these two things because virtual functions need to look into the object, and I really didn't want 2 dot square root. There are several cases where you need 2 objects to get something done. The classical example is multiplying a vector and a matrix. They cannot be members of, it cannot be members of both. So you need 2, or you need to extract it out and make it a free function. And I decided to extract it out. That's the other reason for having friend functions. Friend functions is really the fundamental thing, the thing that we've always had. And maybe I just made a mistake calling them friend functions. It sounds strange and unusual. They're just functions.
Yeah.
Yeah.
Cool. All right, next one. Is C and C++ diverging? Is backward compatibility no longer as much a concern?
I am a very great fan of compatibility and of stability over a long time. And there are people who want C and C++ to diverge. I'm not one of them. I argue against diversion, against new incompatibilities, and most of the time I win that argument. Because it is valuable to have as common a language as possible, and have a community that can exchange information and ideas without artificial barriers. So there has been cases where C and C++ has gone closer. There are cases where C has adopted C++ features and done it imperfectly. They tend to introduce incompatibilities when they adopt it, because not everybody shares my view that they should be in common. Ideally, C should be a subset of C++. That has been the ideal from day one. On the other hand, I had to diverge because C couldn't adopt the type checking. It took them 10 or 20 years, depending on how you count, to make sure that square root of 2 didn't crash. Because as long as you could do a function prototype that didn't declare the argument type, it will crash. And I think that only was outlawed a decade ago. So I decided for a language that was based on static type checking and static techniques and provided overloading and such. I just couldn't allow that. So there I had to diverge. And it has come back, and C is now more compatible with C++ than it used to be. But in other areas, there's minor differences. But strong compatibility, strong stability is are my ideals.
Sorry, I was on mute. Interesting one. What do you do when you want to take a break from C++?
I try not to look at my email. And I usually fail. Usually, I mean, my work has a lot to do with C++. It's not building it, it's using it, but it's hard to get away from. Hey, this is Sunday morning here.
Oh yeah,
it's hard to get
Sorry
away.
about it, but thank you very much for joining. I have to still say.
Yeah, sure, but no. So I don't have a really good answer to that question. If I knew, I'll get more time off.
There's a question which is on the other chat. It is not upvoted, but I'll take it because it's an interesting one. It's a little long one. We always associate C++ with high performance, but performance engineering itself is very complex. We all want to write fast code possible, make fast code possible, but keep drowning every now and then. You seem to have emphasized on learning and sticking to basics in your talk, beauty of primitive C++. What is your advice on writing high performance C++ code, or how do we approach performance when we are writing in C++?
Okay. I recommend taking a thorough look at the problem area, and then deciding what are the high-level actions you want done, defining a high-level interface to the work so that you can get the simplest possible way of expressing the ideas. Now, doing that way means you can do high-level optimizations behind the interface. If the interface needs extra controls, you can add them as optional arguments or something like that. But in that approach, very often people then tend to over-constrain and not get the benefits they want. But the point is, first express what you want to do from the user's point of view, and then optimize, then tune. Once people have expressed what they want done, you can then start tuning the program. You can provide a special version for a special data structure maybe, or you can specify two alternative implementations where there's a general one that can do everything and the specialized one that does something particular. Concepts allows you to, or overloading allows you to select that at compile time so you get the right version. A lot of the standard library is exactly like that. It does a static compile time analysis to figure out if it can apply the optimization. Do you do initialization by a loop, or do you do a memset?
Oh yeah.
Don't let the user do that. They'll get it wrong. Have the standard initialization operation that chooses based on type whether it can be optimized. There's a lot of techniques in that domain. And then you can do things like you want something done to a vector. If you've got 10 elements, there's no point in parallelizing. Oh, yeah. If there's 1 million elements, there might be a point in parallelizing. The standard library allows you to state whether you are interested or not. The implementation are not obliged to be stupid.
Oh, yeah.
If you want a template, if you want a thread version and there's only 10 elements, it's quite capable of figuring out that it can be done very well with one thread and the one you're on now. But basically, have a good interface, do the most static analysis you can to choose the alternatives, and then go and do dynamic things looking at the actual parameters. And then this applies recursively. So, and a high-level implementation usually uses some underlying interfaces, underlying facilities that themselves has this property of being tuned. C++ is tunable.
Right.
I mean, you can, and I've seen, work all your way down and do an FPGA implementation at the bottom. And what you want to do, that problem with the FPGAs is you can't update them fast enough. It's too hard to code, it's too hard to install. On the other hand, you can do the static selection to figure out whether you are in the simple and important case where you do FPGAs, and that can be stable. And when you want to do experimentation, you want to do less performance critical things, you just do it in software. And once you figure out that actually that one was important, you can then work back to it. But basically, my view is that you start from a fairly high level and think of the rest as tuning, optimization, selection based on properties of the argument or the type.
And that what you were building in the talk that you presented with the primitive C++, did you progress that beyond the...
Oh, that's I stated at the talk that I'd made a major mistake of not using concepts.
Oh, yes, you did.
That was even worse than I thought. That is, what I presented worked very nicely for some of the simpler examples, but it got too hard to tune at those cases where it didn't work too well. I have gotten it today to something that I think solves all of those problems, but I am reluctant to put it out because I haven't tested it well enough. It hasn't been used in anger for something that is genuinely high performance, ultra low latency that it's aimed for. So it could be seen as a toy example. And I didn't think it was a toy when I made it. It was a small experiment, but I didn't think it was a toy. I don't think it's a toy now, but a lot of people will look at it when I let it out. And it would be really embarrassing if it didn't do things right. But basically, without concepts, I couldn't do the static resolution of some of the things I needed to get done. And the result was that the performance wasn't good enough in more complex cases, where I really had to choose the right case statically rather than dynamically to get the performance. The simple cases, everything I said in the talk were correct.
That's correct.
Including the bit that I put my foot in it by not using concepts, because they actually turned out to be the key to handling the complexity, the further complexities.
So, aware of time, I guess. What's the time? We still have, if I tell you, we still have 20 unanswered questions, but I don't think we have all day left.
Also, isn't there something coming up in 6 minutes or something like that on your schedule?
Oh no, this is the last one actually.
Okay, let's take 10 minutes more. Let's take 10 minutes more, something like that.
Okay. Okay, super. Thank you very much.
Then I could do with some breakfast.
Oh no, you didn't. Okay. It started at, yeah, you joined a little early, 0715, I guess, your time.
Okay. Anyway, let's
Thank you
go
very
10
much.
minutes or so more.
Okay. Okay, right. So seeing you very positive upward trend on in the popularity, seeing a very positive upward trend in the popularity of C++ in recent times, what do you dream like where the C++ should land in the next 10, 20 years?
I don't know. C++, in my opinion, belongs in this place, touching hardware, dealing with complexity, basically the engineering-oriented uses of programming. And it has nicely filled that domain over the years. And so the correct answer is, I hope it to be a major part in that part of the programming world in 10 or 20 years too. But it never was and never will be the language for everything and everybody. It has a domain. It's a very wide domain, and it has grown consistently since I started, but it's not everything.
Okay. How can we have ISO C++ meetings also in India?
First, India has to join SC22 and W21. And if you join, send representatives, I'm sure we would love to come and have a meeting in India. We were supposed to, the East Europeans have been joining lots of countries recently. Israel has been joining. So we were going to have a meeting in Bulgaria, but the virus got in the way. In earlier years, we've had meetings in Australia and Japan. Any organization that's a member and has taken part can invite. And we're quite adventurous.
Sure.
But first you have to be members.
To start. Yes.
Yeah.
It's a dream. We need a few blessings and luck.
Yeah.
To move things.
I've enjoyed my visits to India, so that's fine.
Good. What did Dennis Ritchie think about C++? Was he involved in any way during the development of C++?
Not much. He was a little bit worried about the function argument checking, which he thought that you couldn't see what was going on. You had to look at the declarations. And in the early days, header files were not universally used. And so you had to go and find the declarations and such. And if you scatter declarations throughout the program, how do you know which ones were right and things like that? So he worried a bit about that. On the other hand, he helped me design Const, the C++ version, not the C version. Right. And we're talking about what he called fat pointers. He proposed fat pointers to the C committee, and they rejected it. A fat pointer is a pointer with an associated member count, so that you can say that this pointer points to 93 elements, which is, of course, a very good thing to have. And you can do optional range checking, and you can do range fors. And today it's called span.
Span. C++
STD span. That's what Dennis called a fat pointer. And I'm sure he would have loved it. Of course, C doesn't have it, but maybe one of these days. C++ has it. Yeah. This is an example of building something that really is quite low level.
Indeed.
It doesn't deal with lists. It's contiguous. It's that kind of stuff, but it runs fast and solves a concrete problem. This came out of the core guidelines, by the way.
It did, yes.
We were trying to figure out how to manage this kind of stuff, and I think it was Neil McIntosh who first suggested it, and I joined that one enthusiastically because I've been looking at that problem before and knew it was a good solution. And if somebody else is interested in it, I'm very interested. And so we built it and proposed it to the committee, and it's now in the standard. And of course in the GSL, the Guideline Support Library, where it originated.
Where it came from, yes.
Yeah, and so I had lunch with Dennis sort of most days for 16 years. It's, still talk to Brian every 2 or 3 weeks.
Oh, cool.
I mean, the old Bell Labs community was quite strong. Really smart people, some of them really nice. And it was a great place to be.
One question, and that's it.
Oh, by the way, I should add that Dennis was a real gentleman. He was great.
Yeah, we miss him. Vedant asks, I recently, okay, no, sorry, it scrolled off. That's not by voting order. Which type of industries do you think that will adopt C++ again?
Again? I don't know. It's all over the place, and it's always been all over the place. I don't have a good answer to that question. It's too general.
Yeah. Madhur asks, what is your favorite language except C++? Danish?
I never answer that question because it always gets confused.
Yeah.
You should know and use a variety of languages, but I try to keep up, and I very often fail. But trying languages. One of the rules of thumb is if you want to learn something, it's much better to learn with a group of friends. So the other language should always be something that some of your friends were using for something. That's the ideal. And so if I have friends doing something, I'll try that.
Oh yeah. Okay, shall we call it a day here?
That'll be fine with me.
I guess we still have 22. You see, the questions just keep on coming, just like you have.
That is the problem. It is de facto infinite.
Yeah.
it grows as fast as we can
answer that.
Yeah.
Yes.
Yeah. Okay. So
thank you very much
for inviting me. Yeah.
Yeah, and thanks
for inviting me. Yeah. Okay.
And
bye.
Thank you very much for starting this. I guess it's the first time I'm talking to you, so I have to say it. It's what we love to do.
Yeah. Okay.
Thank you.
Yeah.
Thank you. You have a good
Bye.
weekend.
Bye.